Welcome back. So, in our last part, we landed on a really crucial idea, right? That AI failures, things like hallucination, bias, and just its general unpredictability, these aren't just simple bugs you can squash. No, they're actually built right into the very structure of how these models work.
Okay, so where do we go from there? Well, today we're going to tackle exactly that. We'll start by quickly framing the problem these limits create. Then we're going to dive into three key solutions you'll hear about all the time: RAG, grounding, and guardrails. And stick with me because this all builds to the main takeaway: why the system around the AI matters so much more than the model itself. And then, of course, we'll tee up what's coming next: AI that doesn't just answer, but acts. So that brings us to the big question, the one anyone trying to use AI for real-world work has to ask. If AI has these predictable, built-in limits, how on earth do we make it safe and usable in practice? Because, let's be honest, if you don't have a good answer for this, you're looking at some serious risks. And that's why you almost never see a raw AI model just released out into the wild. It always needs a support system.
All right, let's look at the first layer of that support system. This one is all about dealing with one of the biggest problems we've talked about: factual invention, or what everyone calls hallucination. The main tool we have for this is a technique you'll hear a lot about. It's called retrieval augmented generation, or just RAG for short. So, what exactly is RAG? Well, you can think of it like this. It exists for one simple reason. Language models do not check facts on their own. So what RAG does is one core thing. It goes out, finds relevant external information, and then feeds it to the model before the model even tries to generate an answer. Now, what it does not do is make the model suddenly understand truth. That's not how it works at all. We're not making the model smarter, we're just changing the task we give it.
Let's walk through how that works in practice, step by step. First, you ask a question. But here's the clever part. Before the AI model even sees your question, the system goes and searches a trusted knowledge base, like your company's internal reports or policy documents. It finds the relevant snippets of text. Then it packages up your original question along with that information it just found and gives the whole thing to the AI. The AI's job is now to generate an answer based only on the material it was just given. It's really just like an open book exam. We're not asking it to remember anything, we're handing it the exact page from the textbook it needs. And this is the absolute key takeaway for RAG. It fundamentally shifts the AI's job. Without RAG, the AI is basically guessing from memory, trying to recall patterns from its huge, messy training data. But with RAG, its job changes completely. Now, it's just referencing a specific source that we provided. It's not a memory test anymore, it's a summarization task. And that is a much, much more reliable and constrained thing for an AI to do, which is why it slashes the risk of it just making stuff up.
Okay, so that's RAG. It provides the right information. But that brings up the next logical question, doesn't it? How do we make sure the model actually uses that information correctly? Well, that's where our next layer comes in, a broader concept called grounding.
So, what's grounding? You can think of it this way. It exists because an AI's outputs need an anchor to reality. They can't just float free. So what grounding does is one core thing. It forces or constrains the AI's response to only use trusted sources. But again, it's not magic. It does not guarantee correctness in every single case. To go back to our analogy, if RAG is the open book exam, grounding is the part where you have to show your work and add citations.
And you can really see the difference this makes. An ungrounded response can sound incredibly confident, but be totally wrong, just a guess with no basis in reality. A grounded response, though, is different. It explicitly links back to its source. It says, according to this document, here's the answer. That makes it verifiable. You can actually check its work.
And this isn't just a neat idea, it's a core principle for making AI safer. Major scientific reports on AI safety have confirmed that giving models access to knowledge databases is one of the best ways to improve reliability. But, and you knew there was a but coming, citations alone are not a silver bullet. They aren't an absolute guarantee of truth. And here's why you have to be so careful. AI models can and do hallucinate their sources. They will literally invent citations. There was a medical study in 2023 that found over a third of the references an AI generated were just made up. Fake papers, fake authors, it's pretty wild. And that is exactly why, for any high-stakes use case, think law, finance, healthcare, you absolutely must have a human in the loop for final verification. There's no getting around it.
Okay,
So we've got a system to feed the AI facts with RAG and a system to make it cite its sources with grounding. But that's all about factual accuracy. What about the AI's actual behavior? How do we control what it's allowed to say or do in the first place? Well, for that, we need our third layer, guardrails.
So, guardrails. They exist because, for any serious use case, an AI's behavior has to be constrained. You can't just let it do anything. What guardrails do is one core thing. They limit what an AI is allowed to do or say. But, and this is important, they do not replace human judgment or responsibility. The bowling lane analogy is perfect here. Guardrails are like the bumpers. They don't steer the ball, but they do keep it from flying into the gutter. They define a safe field of play.
And these controls usually work together in layers. You can start with simple policy constraints, just writing out the rules of what the AI can and can't talk about. Then you can add another layer, things like output filters, or even smaller specialized AIs called moderation classifiers that act like security guards, scanning everything going in and out for violations. And for the really important stuff, you build in the ultimate guardrail, a human-in-the-loop checkpoint, where a person has to give the final yes or no before a high-stakes action is taken.
So what's the catch? Well, there's always a trade-off, isn't there? Guardrails trade flexibility for safety. The more you lock the system down, the safer and more predictable it's going to be. But at the same time, you're also stifling its creativity and flexibility. And finding that perfect balance is one of the biggest challenges when you're designing an AI system.
All right, let's pull the camera back now. We've talked about RAG, grounding, and guardrails. And all three of these tools really point to one single, incredibly important idea. This is probably the biggest takeaway of our whole discussion.
And it's this. Trustworthy AI isn't something you find. It's something you build. It is an architectural achievement. It's not about searching for some mythical, perfect model. It's about the hard work of designing a robust and thoughtful system around the model to manage its flaws.
And this really gets at a huge shift in thinking. The model-centric way is to just chase bigger and bigger models, throwing more data at them and just hoping that somehow makes them more reliable. It doesn't. The smart approach, the system-centric approach, is totally different. It starts by accepting that the model will have flaws, and then focuses all the effort on building an architecture, with grounding, with controls to manage that risk. That is how you build reliable, enterprise-grade AI. You know, when you hear about big enterprise AI failures in the news, a system giving out dangerous advice or causing huge brand damage, it's almost never because the model had a random bad day. No, it's a design failure. The real failure was not having the right architecture, the right guardrails, the right system in place to begin with. So now we have a solid understanding of the systems we need to build to make an AI reliable enough to just answer questions. That's a huge step, but it's not the end of the story. The next logical step is, what happens when we let the AI start to act on its own?
And that's exactly what we're going to cover in our next and final part of this series. We're going to dive into the fascinating world of AI agents. These are systems that can perform tasks all by themselves. We'll look at how they use tools, how they can interact with other software, and most importantly, we're going to talk about why giving an AI the power to act is a whole different ballgame with a much more serious set of risks than just having it answer questions.
So, as we wrap this up, I want to leave you with this one final thought, which really is the core of everything we've talked about today. Reliable AI is built, not discovered. The path forward isn't some treasure hunt for a perfect model that never fails. It is, and always will be, a disciplined engineering process. It's about building systems that acknowledge and manage the very real flaws that come with this powerful technology.